Friends, welcome to our channel. In this session, we will discuss the first order rule learning. So, many learning approaches for implementing first order logic uses a programming language Prolog. Uses the Prolog as a programming language. So, generally, these Prolog languages are Horn classes. This Prolog language has Horn classes. That is, only a single literal is placed in the head of the rule. A single literal is placed in the head of the rule. First we will discuss what are the different types of representations in the first order logic and Prolog. Consider one example, how that example is represented in the first order logic and the same example is represented in the Prolog. Suppose in first order logic, for all x, suppose some function is the body part of x comma some y. Suppose whatever the example, for all x, body part of x comma, suppose some example, pair of x comma pair of gives to some fish of x. This is the representation in first order logic. For all x, a body part of x comma pair of gives to fish of x. Suppose if the same representation, that is if the same concept is represented in Prolog, that is fish of x, body part of x comma pair of gives. See this one, almost same. For all x, body part of x comma this one to this one. So what are the main differences we are observing? We are observing three main differences. The first one is in Prolog they are written in back to front. See this one, this is the end, this is written on the front. This is the front, this is written on the end. They are written in back to front, that is written in head if body. This is the meaning. If this is satisfied, we are writing head. See this one, head if body is satisfied, we are writing this one. And one more is here, this is the capital X. This is the capital X. That is the variables are written in capital letters. Variables are written in capital letters. And all the constants, predicates and function symbols. So Prolog, function symbols are called functors. Remember, in Prolog, the function symbols are called functors. All the constants, predicates and function symbols are represented in lowercase. That means, suppose see this one, here I am writing this as gives. In the previous example, I am writing capital G. Suppose in this is the function symbol gives. And the third one is variables are implicitly, that is by default, variables are implicitly by default universal quantifier. Variables are implicitly, that is by default, they are universally quantified. These are the some of the differences we are observing between a first order logic and Prolog. Now suppose consider an example. If the variable is present, how the variable is present both in the head and body to the variable that is present only in the body. So the difference is, what is my next example? My next example is, consider a variable that is present in both head and the body to the variable that is present only in the body. Suppose my Prolog representation is some animal of x. Body part of x comma pair of y. Some animal of x, body part of x comma y. Suppose this statement is represented in two types of classes. Suppose this is the prologue class. This prologue class has equivalently written by using two rules, by using two first order rules. Suppose for all x, for all y, for all x, for all y, body part of, see here we are using small, here we are using capital, body part of x comma pair of y, x comma pair of y to some animal x. This is one way of representation. Second way is for all x, there exists y, body part of x comma pair of y to some animal x. How we are reading these statements? For all x and y, for all x and y, if x has y as the pair of body parts, for all x and y, for all x and y, if x has a pair of y, x has a pair of y as the body parts, then x is some animal, then x is some animal. Now see this one, for all x, if there exists some y, for all x, if there exists some y, if x has a pair of y as the body parts, then it is some animal. Observe the difference. Here this y belongs to this body only. Here x belongs to, in this case, y appears both y appears for the entire terms. But in this case, y is present within this one. Y appears within this part only. Within this part only. That is, this is the x is the universal quantifier. In this case, y is the essential quantifier. Y is the essential quantifier. Suppose if any variable present inside the head only, if any variable that is present inside the head but not the body, that variable is called local variable. Those type of variables are called local variables. This is the difference between the variables. Now, okay. Now what is our aim? We have to find out order list by using first order. We have to identify the first order rule list. So we are using the same algorithm, that is the length rule list algorithm and rule learn algorithm. Length rule list, and for single rule we are using length rule algorithm. So one more additional thing is, in the first order logic, one more additional point we are doing is adding literal to each prologue class. Adding literal to each prologue class. This is the one of the difference we are observing. So one of the difference we are adding is adding literal to each part. The literals are enumerated. That is how we are expanding the literals. The literals are enumerated by adding predicates, functors, constants, body parts, etc. Consider an example. How the literals are enumerated? Consider a binary predicate. An example, a binary predicate body part. Binary means it produces two values, either true or false. Consider a binary predicate body part. Suppose a unary predicate pair of. That is the pair of. If it is present, yes. If it is not present, no. A pair of unary part. And the constants, gills, suppose the tiles, and the constants, gills and tiles, and use some such of the variables, and use these different types of variables. We are expanding different combinations of letters. Now we are expanding different combinations of letters. That is body part of x comma y, body part of x comma pair of y. Body parts of x comma pair of z. Body part of x comma pair of gills. Similarly, body part of x comma pair of tiles. Suppose our constants x comma pair of tiles and so on. It generates some hypothesis. Suppose if we are using this pair of in a hypothesis, generally it generates the infinite number of combinations. It generates the infinite number of combinations. Suppose consider an example. Suppose if you are identifying the relationships among the letters. If you are identifying the relationships among the letters, automatically we can provide the relationship among the clauses. Relationship among the letters, automatically we are providing relationships among the classes. Suppose consider an example. So point is clear. Relationships among the letters, we are generating relationships among the classes. Suppose the fish of x, body part of x comma y. Fish of x, body part of x comma z. Fish of x, body part of x comma pair of gill. Suppose here also x comma pair of z. Suppose consider the example. What are the meanings of this one? The first class specifies. Suppose the class 1, class 2, class 3. The first class defines everything. The first class defines everything with some body part. To be a fish. That is, this is the general case. It defines everything with whatever it is. Defines everything with some body part to be a fish. Suppose the second class specializes. That defines everything. The second class specializes to define everything with a pair of unspecified body parts. Suppose assume z is equal to unspecified. See this one. The first part defines. So this one defines everything. That contains a body part. This is a specialized version that defines everything that does not contains any body parts. It defines everything that contains the body part as the gills. Suppose how we are identifying the relations. If we are using hypothesis, generally we are moving to some specialized one. To predict a particular rule, we are not dealing with the general case. We are dealing with step by step. We are dealing with a general terms. That is specialization. The simple meaning is here the terms are replaced. So no need to write this many. The terms are replaced by using the variables. The terms for the variables are replaced by adding equality letters. That means suppose fish of x is equal to body part of x comma y. Suppose here x comma pair of z. Here I am writing this one as x comma y. Y is equal to pair of z. I am writing in this fashion. Suppose the pair of z is replaced with y. Pair of z is replaced with z. Okay. Suppose z does not contain any specified parts. Suppose here I am replacing as y. Here y is equal to pair of z. Z is equal to, that is, z means does not contains any parts. So what is the value of z? Z is equal to gills. Observe the meaning. In the previous case, we have only a general case. We have a general one. Now this is the general one. Step by step, depending on our requirement, we are replacing the variables with their equal letters. Suppose all have three causables. See this one. The entire is constant. Here instead of y, this replaces. Instead of y, it replaces pair of z. Now z is replaced with gill. That is the searching heuristic. That is the searching process is reduced. The search process is reduced. Now, and the final one is the general and specialized one. For example, body part of x comma some scales. Body part of x comma some scales to body part of x comma pair of gills. See this one, body part of x comma scales to body part of x comma some gills. Suppose the first one is written as fish of x, body part of x comma scales. Similarly, the second class is body part of x comma. What here we are doing? Suppose this is the general one, the first of the two hypotheses. Suppose this one, the first of the two hypotheses, this is the more general. This is the more general one compared to this one. That is the scales means for all the futures. Gills means if it contains only gills, that is the future. Observe the thing. Here the first order rule learning is similar to the rule learning in the rule order list and unordered list. Here the only difference we are using is, instead of writing those rules, we are written in the prologue. We are written the rules in the prologue fashion. So these are the cases. So the concept is very simple. First, the implemented in prologue. Second one is the representation in first order and the representation in prologue. What are the differences? That is second one. Third one is how the variables that are present both head and body and only body. So for that I am considering one example. And the next example is the rules are in order, that is enumerating the letters. By considering some examples, that is a pair of body part, and write down all possible cases. If the pair of is a hypothesis, that is an infinite case. So infinite case. Okay, that up to now clear. Suppose consider an example. So the example has three classes. The example has three classes. One is x comma y, x comma z, pair of z, x comma pair of x. So the search is complicated. To reduce, we are replacing the variables with their equal terms. So we are seeing the examples. And finally, this is the general class. This is the, suppose just a representation. This is the general class. This is the specialized class. This is represented in this fashion. That is, a specialized comes under general. We are represented in if this is the head body. If this one, automatically this one. If fish has a gills, automatically it comes under scales. Gills automatically comes under scales. Okay. This is the first order rule learning. Thank you.